Thanks, everyone. It's great to be here. How's that sound? Is that a bit loud? Cool? Okay, great. Um, okay, scaling privacy and interoperability. Not insignificant topics, and it's good to be able to be here to discuss them, and especially good to talk about zero knowledge, right? Because we believe at Mina Protocol that zero knowledge is key to unlocking scaling privacy and interoperability for crypto in a trustless way that's sustainable over the long term. Thanks everybody for joining after lunch. Everybody's probably a bit tired, but let's do this. So, as I said, my name is Brian McKenna. I'm head of product at Mina. I've been at Mina now for 2 years. A bit of background about Mina is that it was incubated as Coda Protocol, and it launched into mainnet as Mina Protocol in about 2 years ago. And this is a really nice time to speak, actually, because we're at a really important inflection point in the protocol now. So we launched with what we call a succinct blockchain, and we'll get into in the talk what that actually is. We launched with a open participation proof of stake consensus based off Ouroboros. And we're about to hard fork to add zero knowledge applications to the network. So building out the ecosystem with this new type of a smart contract framework that brings the benefits of ZK to computation, basically. And we'll get into what that is. I mean, we've seen, especially in the Ethereum ecosystem, that ZK is being used for scaling with the ZK EVM work and ZK rollups and things like this. And we're going to talk a little bit about that today, but we're also going to talk about how ZK can be used for actually applications and programming and the benefits that it brings to that. So we're going to talk a little bit about privacy. Privacy is one of the key features of zero knowledge generally. Just a little bit about what ZKPs are for anybody who needs a refresher. Overview on Mina, and then ZK apps, and then looking at some of the use cases that are building on Mina right now. So let's talk about privacy. We don't have very much privacy in our day-to-day lives in Web 2. I think we've actually lost the privacy battle in Web 2. And the privacy battle in Web 3 is still taking place, I would say. Like the transparent nature of blockchains is one of the things which makes it really cool. But with the advent of ZK, we believe that we can embed privacy features such that like the user can keep the key things about themselves private, and businesses can do the same for their business logic and their transaction history. And we feel that, like, well, as it's defined in the United Nations, that privacy is a fundamental human right. And if Web3 is to scale to billions of users, then some privacy features are going to be required. And like one of the things that we like to say about zero knowledge applications is that it allows for programmable privacy. So it allows the developer, for whatever their application is, to define what kind of privacy that their users should kind of receive in their application. And we'll get into how that actually works in a second. But let's try and define privacy here. It's kind of a hard thing to define, but we can define it as the ability to decide what you want to share and who you want to share it with. And like I think we can all agree that that's like a basic principle of, you know, of life, really. And we want to apply that into blockchains. So this is about the evolution of privacy and security over time. So like with Web 1, we had static web pages with privacy concerns. PGP launched. We had no payments. I mean, ideally, the internet would have launched with payments and privacy, but it went off and it took off, and those features were never built in. But I do think that they were in the ideology of the early builders of the internet. With Web 2, we do have some privacy in that when we log into our bank accounts, other people can't see our bank accounts, but we don't have privacy from the centralized server who actually looks after our data there. And that can be said for social media, for basically all of the apps that we use today. Yes, and there's no real digital asset transfer, especially in a decentralized way. So what do we want to build into Web3? So we want to build in like no centralized trust. So we want to be able to make payments, operate our digital lives while not leaking all the information, and having that information like resold and kind of used like in the business model of these Web2 entities, right? So we want to move from like a centralized server model to decentralized server model. We want to be able to like make payments, port assets in a decentralized way. And really we want to just completely reduce the need for any intermediaries for all of our digital footprint, right? When it comes to payments and applications, I would say. So where are we at with this today? So the tools are being built, but they're not yet ready for mass market, but we're getting there. Also, importantly, regulation is evolving, and we need to find a balance with regulators as they learn about this type of technology. So let's just have a quick crash course on zero-knowledge proofs. Who knows what zero-knowledge proofs are already? Okay, that's good. That's a really good start. So, I mean, people always say that this is like some kind of like cryptography magic, but really zero-knowledge proofs are the ability to prove something to somebody without revealing like the underlying thing that you're telling them, right? And you know, if people look at you in disbelief when you tell them that this is possible, but you know, it actually is. And it's actually possible in production systems today, which is like really amazing. Even going back, you know, single-digit years, it wasn't possible to even have the compute power to be able to process these things. So it's really like, it's really a powerful place that we're in right now to be able to roll out this kind of tech for users. ZK snarks specifically are efficient in that they're constant size. And we'll talk about the kind of scalability benefits that brings in a second, but one of the key things that these bring are privacy. So, as I said, you can prove something to somebody without revealing what that thing is. And when that comes to applications, this is developer talk. So the developer is able to define the inputs to the contract, and they're able to define those things as being public or private. And we'll get into a second how that works. So let's just talk about the current state of Mina. Blockchains have a time and a space problem. Time in that we want to process, you know, billions of transactions, but a space because to have that verification, to check the state of the chain, like from full node security, all those transactions need to be checked all the time and they need to be stored on the node. So the current state of Mina is that we have a succinct blockchain, which means that using the ZK snark, the blockchain is fixed size in that the proof of the state of the network is stored, like it's recursively proved, like block after block after block after block. And this brings some really like important decentralization benefits in that somebody doesn't need, for full trust for the blockchain, somebody doesn't need to like run that 400 gigabyte or terabyte node to like achieve what they want to do for full trust. They can just run like the 22 kilobytes, and they can run that from their device, right? They can run it from their browser or their smartphone, which is a really important thing because if we're talking about trust minimization, probably if you're on the former there, you're going to want to use a centralized intermediary to actually talk to the blockchain for you. In the latter, you're going to talk to the blockchain yourself. So this is the first way that we've used ZKPs, which, if we think about the rollup space, Mina is essentially a rollup of itself, block after block after block, because all of the previous transactions and all of the previous blocks are rolled up into the current block. So before we get into a little bit more of the detail, it's like, what kind of things can we build with zero knowledge? So as I mentioned, we've seen the first kind of wave of innovation is coming from scaling. Because that's where the current requirement is, right? We need to scale. And ZK rollups and ZK EVMs are the first way that ZK is being used. Other things are private transactions. And these are things that are all possible in Mina, by the way. So like ZK rollups, ZK EVM compatibility is possible. One could build a private payment system on Mina. Not only that, one could actually build a ZK identity system into private transactions, so that somebody could prove that they're KYC'd, for example, or they could prove something about their personhood, such that the settlement of the private transactions is based off, like the fact that the person has proven something about themselves. So it's not just a completely like dark pool. And that gets back to the notion of programmable privacy, right? It's not black or white. The developer has the option to be able to create the type of system that they want with the type of privacy that's required for users and for regulators and for, like for production businesses and applications. Private voting is a really cool thing for even things like surveys and like, polls and things where people want to like take a lot of information from people, but the person might not necessarily want to reveal their identity or how they voted or what their views are. And it's also relevant to blockchain, right? Because DAOs are becoming more and more important, and we don't necessarily want to see our DAO votes all transparent on chain. And we're going to get into this in a second, but being able to verify like large computations without putting all that computation on chain. We see with like machine learning and AI and things that are coming along right now, these things are happening so fast, but we're probably going to want to verify the integrity of AI models, and because there's going to be so many that we're going to want to make sure that like, something, was computed by this AI model or wasn't computed by this AI model. Otherwise, we have to trust. Well, we can't really trust the integrity of like what we're building off. Yeah. So quick overview of Mina. As I mentioned, ZK apps are on public testnet right now. So like, there's builders in there building. There's lots of developer resources, tooling, Discord, and there's an accelerator program, which I'm going to speak about at the end. And we've already mentioned like the efficient verification and interoperability. So efficient verification using zero-knowledge proofs, and actually interoperability also using zero-knowledge proofs. So I mentioned before that Mina's state is rolled up into the current block. So the current block is a representation of the current state. That state can be provided to other chains and verified within those other chains. So we're just using this Mina 2 Ethereum, for example. We've already built this bridge, for want of a better word, but what it really means is that a developer in the EVM can call Mina state right from inside the EVM. Because the Mina canonical state contract in the EVM will get verified by Ethereum itself as being a correct Mina state, and B, also like the strongest and latest Mina state, which is really powerful, right? Because we look at the problems that we've seen in crypto or the things that we need to solve for. Scaling has been like ongoing over the last few years, and we're making progress there, but bridging is definitely something that we need to make progress on. We've seen all the hacks, we've seen all the funds lost, so using ZK for trustless interoperability is a really powerful use case. Yeah, so ZK apps themselves, so ZK apps offer general purpose ZK programmability, written in TypeScript using or Snarky.js libraries. I think what's significant about like taking a step back and bigger picture here, what's significant about this is that zero knowledge was only available to like deep cryptographers and mathematicians only a few years ago. In fact, not many people in the world could like write code that uses zero knowledge. So it's really awesome to be able to open up zero knowledge programming to a much more developer audience. The reason we chose TypeScript is because, well, A, it's a good language, and B, a lot of people know it. So we wanted to optimize for accessibility. So like one would need to understand or learn TypeScript. They would need to understand basically how blockchain works. And they also just need to understand how the abstractions work when it comes to programming in circuits below. But like the key thing here is that somebody doesn't need to understand or be able to write like zero knowledge circuits themselves, which is like really cool. So we're going to get into user privacy and scalable verification, like how that's achieved. ZK apps support like full recursion and composability between contracts. And appropriately for this venue, our proof system is called Kimchi, which is, it's open source, there's no trusted setup, and it's extensible, and we're working on it all the time. Yeah, so just to recap, Mina right now is a succinct blockchain. It's stored in 22 kilobytes. What that brings us is that it's available on full nodes and browsers, which is really good for decentralization. And we can also use the snark for bridging. But let's get into applications. So ZK apps, the framework for programming in ZK apps is quite different than normal dApps. So normal dApps use on-chain computation. So what this means is that as a user, from my little screen there, I'm going to send an update to the smart contract, which is basically a transaction. And that transaction will get sent to all nodes on the network and processed by all nodes on the network. And all nodes will say, hey, is this a valid state update? Yes. Okay, update state. And now imagine like millions of transactions happening at the same time. This is going to form a queue, and the nodes still have to process every transaction. Therefore, they're just going to up the gas cost, right? Because just the network's going to get busy, because every transaction needs to be processed by every node. Not only this, when a new node joins the network, they have to reprocess every single transaction that's ever happened since Genesis, which is quite like inefficient, I would say, actually. So Mina ZK apps, how do they differ? So this diagram is quite similar to the last one. The key difference is that as a user, as I send my transaction, it's a proof of the update, the state update that I've done locally on my machine. So this proof gets sent to the network. The nodes on the network check that it's a valid state update. If yes, then it updates the state. What's important here is that the compute has been done on the client side rather than around every single node on the network. And the proof of the compute is constant size. So no matter like how much computation I've done, that computation doesn't need to be re-executed by every node in the network. It's a constant size proof that gets sent to the network that needs to get executed. So, I mean, this offers like really efficient, basically compute. We could almost say that there's like infinite compute available client side, if that's something that somebody wanted to do. And then the state update to the network is constant size. So it's small and it's pretty much gasless. It's just a constant transaction cost. So what are the advantages of this? I'm just going to pop back to this one. So as the compute is done client side, the inputs to that computation are not known by the network. So if we go back to this one, everything here gets sent to the network. So like if it's a DEX transaction, for example, like what am I swapping? What's the price? What's my account? and then anybody can see like my account history and like basically my whole trading history. In this model, the developer can say, okay, for my application, I want to keep X, Y, or Z inputs private. So X, Y, or Z inputs private here in a DEX example might be that, okay, I want to keep the user's account private, I want to keep the user's identity private, and maybe even what they're swapping private, right? So yeah, so we think this is like scalable, smart contract model, and also it enables privacy. And like those two things are really going to be required for blockchain to evolve into like something that like everybody uses like all the time. And also businesses as well, because I don't think businesses are really going to deploy things on blockchains without having these properties. Yeah, so just to recap there, user privacy, more useful dApps. It opens up the design space further, so that programmers can build in this type of privacy. No gas regardless of computational complexity. The applications will compose with each other, and they can be rolled up using recursion off-chain. So each app is almost itself like a roll-up. And importantly, it's accessible for non-cryptographers, which is quite new. So this is just a little bit more about it's actually important to say that there's two components of the ZK app. The first one is off-chain, which lives in the user's browser, and the first one is on-chain. So the proof gets created in the off-chain component of the app, and the verification part of the code lives in Mina, and that's the part that verifies the state update, that the computation was done correctly. So we've spoken about ZK apps. We've given a little history about Mina. We said that Mina ZK apps are currently on public testnet, so like the tools are there, the libraries there, the documentations are there, the tutorials are there, and we're just going to look into some of the things, some of the teams which are currently building. So Lumina is the first DEX on Mina, and it's an enterprise-ready DEX in that it's bringing the type of innovation to DeFi, which is going to be required for regulation, right? So currently in DeFi, there's no privacy, and there's no notion of identity, or there's no, privacy and identity are the key things. And also, you don't really know that who you're trading with, except for the pseudonymous kind of nature of the account that you execute with, right? So what we want to do is we want to bring some notion of identity to say, okay, I want to prove things about myself, to say that, I live in X jurisdiction, that I have maybe this trading balance, or that I've KYC'd, somewhere. But, as a user, I don't want to put my personal information on the blockchain. So we're going to create a zero-knowledge proof that, somebody is KYC'd somewhere, and in that instance, the counterparty knows that they're trading with a real person, that they're trading with a real entity, if that's what they want to prove, and they're not trading with somebody that their regulation disallows them from trading with. But the important thing is that none of the user's information actually goes in the clear. They keep all that private. Another cool thing about Lumina is that getting ready for regulated liquidity to come to blockchain, also offering some privacy. So we could have a regulated liquidity pool, we could have a normal liquidity pool, we could have a private pool, and we could have an open pool as well. Part of Lumina is enabled by a project called ZKPID. There's a link down there. The name of the team is called eTonic, and their solution is basically enabling templates and platforms for proving identity using ZK to the blockchain. That's a really important one. The next one, we had scaling in the title, and we've hit privacy, interoperability, and this is an extract from the Mina roadmap, and this is all about building the toolkit to be able to, let's call it a stack. So a modular set of infrastructure to build ZK rollups and highly customized ZK app chains on Mina. So to really scale like ZK apps off the L1, but in a fully trustless way. And many, many more. So I mentioned the accelerator program at the start. There's been, I think, a couple hundred or hundreds of devs through this already, and they've built some really cool things, which were on the previous slide. Timing is really good because the next cohort begins like in a couple of weeks, and you can use the QR code to make your registration. And there's lots of support there from Mina Foundation, from the other developers in the ecosystem. I think there's weekly calls and docs and tutorials, so there's a lot of support there for builders to be able to be successful. And I'm going to run out of time, but I just want to call out that Mina's multi-year roadmap is available on our website. It's kind of this cool interactive thing, and it basically looks like this, except this is like part of one track. And I'm just going to talk about the 5 tracks very, very briefly. The first track is trust minimization. So basically, technical design solutions to maximize decentralization. ZK programmability is all about like ZK apps and extending out our proof system to be able to make faster, better ZK apps. Settlement layer performance is about modifying the settlement layer to make it like the ultimate settlement layer for processing ZKs, especially as it relates to settling ZK rollups as well. Minaverse is all about the ZK rollup ecosystem that I mentioned, and the road to DAOification is the governance track. So like an incremental process to basically hand decision making about Mina back to the community. And it's also interactive. Yep, that's everything from me. I think we had a good time. Perfect. Thanks everyone.